We all know what fracking is. You drill a deep hole, go sideways into some dense carbon-filled rock, fracture it or blow it up with some high-pressure water and chemicals, suck up all the gas that comes out, and that gets pumped into our homes so we can boil water and make lasagna. The gas is also used to make electricity and make plastic. It's actually quite fracking amazing, and it's happening all over the place, especially here in Pennsylvania. But all this high-pressure water has to go somewhere. When you're fracturing, it mixes with all that pulverized rock and comes out of the ground with all the natural gas. And this dirty water is called wastewater, or flowback. It's dirty, salty, and it's also radioactive. To understand why frack water is radioactive, we need to know two things. First, this is uranium. It's unstable, so it's constantly shooting off alpha and beta particles as it decays into other elements, and that's why it's radioactive. And trace amounts of uranium are found everywhere. Second, way back before there were even people in Pennsylvania, the Keystone State used to be under the ocean full of algae. And these algae plants died and collected on the seabed, and after millions of years, the carbon compounds in the plants became the natural gas found in the Marcellus Shale. The same chemistry that trapped all the carbon from the dead algae also trapped uranium. There's 3 times more uranium in Marcellus Shale than in its neighboring rock layers. In fact, looking for elevated radioactivity is how these fracking companies find Marcellus Shale to begin with, because where there was uranium, there's natural gas. And that uranium has been breaking down into other elements like thorium, radon, radium, that are all radioactive. And that's what's in the pulverized rock in this pressurized water. So the water that comes out of these wells is radioactive. Now, although it's radioactive at pretty low levels, here's the problem. If this slightly radioactive water is released into a stream, the radioactive elements like radium and strontium can accumulate in the tissues of living organisms, so as you move up the food chain, the little bit of radioactive material becomes a bigger and bigger problem. The big question is, how do you dispose of it? Turns out there's no good way of getting rid of it. Dumping it in with sewage gets it into the rivers eventually. Same thing with landfills. When you come down to it, there's no good way to clean up this fracking wastewater. So, most of it ends up getting injected back into the ground in deep wells. The thinking being, as long as that water stays deep underground, like 1.5 miles underground, it should be okay. Out of sight, hopefully out of your drink, or out of your lemonade, or out of your mocha almond frappuccino.